We've been working only with the int data type so far in the course. In this video, we'll continue to look at int as well as several other primitive types. We'll also introduce the wrapper class, a special category of data type which offers additional functionality that primitive types don't. In Java, primitive types are the most basic data types. The 8 primitive data types in Java are shown in the table below, listed by the type of data stored for each. You can see from this table there are 4 different types to store whole numbers: the byte, the short, the int, which we've briefly looked at, and the long. There are 2 types to store real numbers: the float and the double. And finally there is the char and the boolean, which are in categories of their own. Consider these types as the building blocks of data manipulation. Remember that primitive data types are simply placeholders in memory for a value. We're going to explore all of these primitive data types in Java over the next few videos. Alright, if you remember from the previous video, we created some code in JShell which declared a variable of type int and assigned it some expression, which we'll do again now. Int myValue equals 10,000, semicolon, then enter. So what that's doing, if you recall, it creates a variable called myValue of type int, and next we're initializing it here on the same line with the value of 10,000. The computer has allocated enough space to store an int, and it's assigned a name for that variable of myValue. But if you're pretty new to programming, you may be asking what actually is an integer and what values can be stored in an integer. An integer is a whole number, meaning it doesn't contain a fractional element or a decimal. There's a specified range of values allowed for the int, which is true for most data types. What this means is that the allowable range of values is not infinite. There's a defined minimum and maximum value for each numeric data type, meaning you can't assign a number bigger or smaller outside of that range. So how do you know what that range is, and is it important to know? We can get that range programmatically for each data type, and there may be times when we'll need to test if a value is in range. Alright, let me first show you how to get the valid range for an int. Let's type in some code in JShell, then we'll review it carefully. Int myMinIntValue equals integer.min_value, semicolon. Okay, so what are we doing here? You maybe could guess, based on our previous discussion, that this is the minimum value of an int data type. You can see that we created a variable of type int and named it myMinIntValue, and we've assigned it an expression. This expression, integer.min_value, will look unfamiliar to you. That's because integer is a wrapper class, which we'll explain shortly, but for now you just need to understand that there are some values stored on this class which we can retrieve by this mechanism. Here we're getting the minimum value allowed for an integer data type. Let's press enter and see what that value is. JShell will echo the value derived from the expression, as we see next. This is telling us that the minimum value you can assign to an int is -2,147,483,648. You cannot try to assign a value less than that to an int variable, and we'll get into that shortly. But first, let's get the maximum value by doing the same kind of thing using a slightly different expression. Int myMaxIntValue equals integer.max_value, semicolon. Now that we know the min and the max values, we can say that the range of values which an int data type can store is from integer.min_value to integer.max_value. Let's use some of the programming skills we've learnt so far to print out that range as a statement to the JShell window. Next, I'm going to show you how to display both text and some non-text data on the same line. First, let's just print out the minimum value in a statement to the console. Instead of just printing the variable as we've done before, we're going to first print a label saying what it is, then print its value. So we'll start by typing system.out.print, opening parentheses, double quotes, integer minimum value equals plus myMinIntValue, closing parentheses, semicolon. The plus sign, plus, when used in system.out.print, will print different data types together as a single line of text. In the example, we want to print a label before a numeric integer value. Whatever follows the plus sign in system.out.print here is converted to a string by Java and concatenated to the string before it. This is perfectly valid syntax in Java. and pressing enter will print out a more informative message for our users. So it's a handy way to combine text with numeric output. There are better ways to print this out, but at this point in the course, the use of the plus operator is perfectly acceptable. Let's do the same thing, but instead of using our variable, we can just use the expression integer.min_value. System.out.print, opening parentheses, double quotes, integer minimum value equals plus integer.min_value, closing parentheses, semicolon. This gives us the same output as before, so we can use either a variable or this type of expression here. And now let's print the range for the integer in a single line of text for our users. First, I'll do this on a single line in JShell. System.out.print, opening parentheses, double quotes, integer value range, opening parentheses, plus integer.min_value, plus, double quotes, to plus integer.max_value, plus, double quotes, closing parentheses, semicolon. It may not be perfectly obvious looking at this statement, but here we are putting a string literal, including a left parentheses we want printed out. Then we follow that with a numeric value, the minimum value. Next we print the word to, and then the maximum value. We end with a final string literal, a single closing parentheses, to make our line of output more readable. Pressing enter, you can see we have nice succinct output, even if that code looked a bit ugly. Let's look at that statement again, but this time I want to do the same thing, but on multiple lines in JShell. Hopefully, you can see more clearly how many times this one expression is using the plus operator. When we introduced JShell, we talked about when you leave a Java statement unfinished and press enter, JShell prompts you for more code with the ... and right arrow prompt. So let's try this now. System.out.print, opening parentheses. JShell is waiting for us to type something in, so let's go ahead and type in the rest of the statement. Integer value range left parentheses. Plus integer.min value plus two in quotes plus integer.max value plus closing parentheses in quotes. Notice this is a string literal and not actually the closing parentheses for the statement. Closing parentheses, semicolon. Looking at the code this way, you can see the expression is made up of three string literals, one of which is a right parentheses only. There are four plus operators, as you can see, and two integer values. Again, not really elegant, but pretty useful if we don't want to constantly be outputting small amounts of information. Pressing enter gives us the same result as before. Let's talk about why we're using integer in the expression to get the min and max value. That's because int is a primitive type that really only gives us the option to set the variable's value. Integer, on the other hand, is what's called a wrapper class. Let's talk about wrapper classes now, but first, to understand them, we need to briefly talk about classes. So what is a class? A class is a building block for object-oriented programming and allows us to build custom data types. We'll be talking more about classes in a future video. Java uses the concept of a wrapper class for all of its 8 primitive data types. A wrapper class provides simple operations as well as some basic information about the primitive data type which cannot be stored on the primitive itself. We saw that min_value and max_value are elements of this basic information for the int data type. The primitive types and their respective wrapper classes are shown in the table below. You can see there that in general, it's pretty easy to remember the wrapper class name for your primitive data type. It's the same name, but with an uppercase letter at the start. The wrapper classes for char and int, character and integer respectively, are the only two that differ in name other than that first capitalized letter from their primitive types. We'll talk more about these later on, but for now, let's take a look at int and the integer wrapper class. In the case of an int, we can use integer, and by doing that, it gives us ways to perform operations on an int. In the code we just reviewed, we were able to use min_value and max underscore value on the wrapper class integer. To discover the minimum and maximum range of numbers that can be stored in an int, as we saw when we printed out these values previously. Min underscore value is the smallest value we can set an int to, and max underscore value is the biggest. Just to confirm that, let's try adding just one to the max value and see what happens. So to do that, we're going to type system.out.print, opening parentheses, double quotes, busted max value equals plus, opening parentheses, my max int value plus 1, close both parentheses, semicolon. So what we've done is add 1 to the maximum value, which technically shouldn't be possible because we've established that my max int value already contains the maximum value of an integer. Press enter and let's see what the output is. Look what's happened to the busted max value. We've assigned the maximum value plus 1 to it, so how is it possible the outcome is a negative number? This is called an overflow, meaning we tried to put too large a number into the space allocated by the computer for an integer. Now it didn't fit, but the computer tried to fit it anyway, instead of throwing an error, and by doing that, it overflowed. The reverse is also true here, and we'll try that for the minimum value. We'll press the up arrow key, and then change the plus to a minus, my max int value to my min int value, and we'll change the text max to min. Can you see what's happened there? In the case of our busted min value, trying to subtract 1 from the minimum value, we've ended up cycling around to the maximum value. This concept is called underflow this time and not overflow. If you try and put a value larger than the maximum value into an int, you'll create something called an overflow situation. And similarly, if you try to put a value smaller than the minimum value into an int, you cause an underflow to occur. These situations are also known as integer wraparounds. The maximum value, when it overflows, wraps around to the minimum value and just continues processing without an error. The minimum value, when it underflows, wraps around to the maximum value and continues processing. This is not usually behavior you really want, and as a developer, you need to be aware that this can happen and choose the appropriate data type. Imagine if you had a counter for your website visits and set it to an int data type. If you were fortunate to reach that maximum value, which we said was about 2.14 billion, your counter would then go negative. As we'll see in the next video, there's a data type to hold much bigger numbers if we need them to avoid situations like this. But ultimately, as programmers, it's our responsibility to use the appropriate data type and also to ensure the range of numbers we're trying to store in that data type is really within the supported range. In addition to the problem of underflow and overflow, assigning a literal number that's outside of the valid range for a variable will throw an error. Let's take a look at an example. First, let's print out what that maximum value is again. System.out.print, opening parentheses, double quotes, integer maximum value equals plus integer.max underscore value, closing parentheses, semicolon. And now we want to assume a value that is the max value plus 1. Int my max int test equals 214748368, semicolon. Note here that the number we've typed in ends with an 8 and not a 7. So it's bigger than the maximum value by 1. So what we've done here is we've assigned a numeric literal to my max int test that is bigger than the maximum value. As a result, this time we get an error. In this case, the number is too large. You might be asking, what's the difference between this and what we did earlier? An integer wraparound event, either an overflow or underflow, can occur in Java when you are using expressions that are not a simple literal value. The Java compiler does an attempt to evaluate the expression to determine its value, so it does not give you an error. Here are 2 more examples that will compile and result in an overflow. The second example may be surprising. Even though we're using numeric literals in the expression, the compiler still won't try to evaluate this expression, and the code will compile, resulting in an overflow condition. If you assign a numeric literal value to a data type that is outside of the range, the compiler does give you an error. We looked at a similar example previously. This might seem like a confusing difference right now, but don't worry, we'll be talking about equation results more in the operator section of the course, and how these expressions are a bit different than literal expressions. Let's just correct that last statement now by changing the last digit back to a 7. And this time, we don't get an error. So any number literal you use, similar to what we've shown in the code sample so far, is assumed to be of type int by Java. There are ways to tell Java otherwise using a character at the end, which we'll get to in the next video. I want to point out one other feature in Java for numeric literals, which is valid syntax, because you might find reading large number literals somewhat hard to understand. In Java, you cannot put commas in a numeric literal. For example, the following is not valid syntax. So Java provided an alternative way to improve readability, the underscore. You can put the underscore anywhere you might want a comma, but you can't use an underscore at the start or end of the numeric literal. Just like how we would use commas in a document to make numbers more readable when we write them out, we can use underscores in Java code to achieve the same goal for any readers of our code. So let's walk through what that looks like in JShell. So we'll press the up arrow key to display the previously typed in code. Then we'll add the first underscore before the last 3 digits. We'll add another underscore before 483, and then the last one we'll add after the first 2. So you can enter it in that format if that's easier for you to understand and to read at a glance. Let's end the video here, and in the next video we'll discuss 3 more primitive types, namely the byte, the short, and the long. I'll see you in the next video.